Hi everyone, welcome back to my YouTube channel. So in this video, we will talk everything about arrays in MATLAB. So let's get started. So here I have made a live script because we have seen the utility of live scripts in explaining things. There are two options. One is the output on the right and the other output below the code. So I prefer output below the code while explaining things. In the start, let's say for the first example, we will define a scalar x equals to 10. Where you can see this output is x equals to 10. Now, whose command is used for checking what is the class and attributes of a variable? So, whenever you have any confusion with any of the MATLAB functions, you just select it and press ctrl-d. So now you are seeing the definition, what is whose and how it is used, what are the inputs used and what are the outputs. So you cannot change these things, but it will give you an idea about how to use these things. So now coming back, so whose is a 1 by 1 scalar value, size is 8 and the class is double. For most of our cases, double is good enough. You can also increase the accuracy, which you will see in the later videos. And when we will be discussing about symbolic map toolbox, then you will see VPA, variable precision arithmetic, and that will be used for higher order accuracies in numerics. So now, we have also defined a matrix. So it's a 3 by 3 matrix with entries are defined along each row. First row contains 1, 3, 5. The next row contains 2, 4, 6. And the last row contains 7, 8, 10. So these all are separated by a semicolon. But we can also write it like this. PB. It is the same matrix as a separated by different lines. And note that the spacing between the numbers doesn't matter. Even if you put it like this and run, again you'll be getting the same output. This spacing, even if it is 1 or 10, doesn't matter. But coming to the next line, actually changes the row, as you can see here. Now, instead of giving these, we also have a zero matrix. This command zeros is used for creating zero matrices. So after zeros, you'll have to write the size. This is the number of rows and this is the number of columns. Now, we can also use ones. For any other scalar value, you just multiply before add. So let's say if I want to have 4, all 4s. Now, for creating vectors, one of the ways is this. So start point is 0, end point is 100, and the step size is 10. So we will go from 0 to 100 in steps of 10. So the output is 0, 10, 20, 30, 40, up to 100. One more way is to use linspace. Linspace is linearly spaced elements. So again, from 0 to 100, how many values that you want? Steps is this minus 1. So if you want 10 steps, so this will be 11. Again, when we are getting the same output. Now, we have defined all these arrays, how we can define the arrays, scalars, vectors, matrices. Now we go to array operations. Suppose you want to find what is the maximum value of an array. So max f can be used. The f vector was like this, the maximum value is 100. And the minimum value similarly is 0. Now we want addition. Let's say the array A was defined like this. Now we want to add 10 to each of the values. So we'll write P is equals to A plus 10. So now P becomes each value added by 10. Instead of 1, you have 11. Instead of 2, you have 12. Instead of 7, you have 17. And similarly along the other columns. Now, also we can use these arrays as inputs to some other functions. Here we use the sign function. Q is equals to sign of A. So any value is used as an input for sign function. So here we are using Q is equals to sign A. So Q will also be the same size as A, but each element will be the sinusoidal value of the value at A. So Q1, 1, this 0.8415 is actually sine of 1. Again, sine of 2 is 0.9093. Now we can also make transpose. Transpose is nothing but rows and columns swapped. So instead of having 1, 3, 5, now we have 1, 3, 5. Now for calculating inverse, now S is some variable assigned as A multiplied by inverse of A. So we know if a square matrix is multiplied by inverse of its matrix, the result has to be an identity matrix. Now you'll see this small yellow underline that says that inverse A, here you can see that inverse A can be slower and less accurate than A backslash B. Backslash is also used for calculating the inverses. So A backslash B stands for inverse A multiplied by B, and B backslash A stands for B multiplied by inverse of A. So here, since both the values are A and A, we can use A backslash A. Now you can say that S2 is more accurate than S. And these all are in double precisions. Now, if I want to square the matrix elements, there are two ways to do it. One is I use this dot multiplication. So each element of A is multiplied by corresponding elements in the other matrices. So 1 is multiplied by 1, 2 is multiplied by 2. Let's just quickly open A as well, so that you see. Now you see T. T is A dot star A. So it means each of the element values is squared. So here you can compare that A11 was 1. So T11 becomes 1. Similarly, A22 was 4. And now T22 is 4 squared, 16. Similarly, all the other values. Now, if I want to cube it, so either you can follow the same steps as A dot star A, or you can have A dot raised to a power 3. Now again we can compare that each of the values are corresponding cubes of A. Now we can also use concatenation. Concatenation means joining of two arrays. So two arrays can be joined side by side or top bottom. So if we separate the two matrices by comma, so they'll be joined side by side. So the first A is this and the second A is this. And if I separate it by a semicolon, then it becomes top bottom approach. So top is the first matrix and the bottom one is the second matrix. Now let's say I want to change some values. I want to substitute some values to other values. So this is 1, 1. B1, 1 is set to 1. But I want to change it to some other value. I can do substitution. I just put the input B1, 1 and substitute it where the value desired. So now you see all the other values remaining same. Only B11 is changed. So this is what we call as indexing. So now we will discuss in more detail what is array indexing. So let's say we have this matrix A. This was A, A. And capital A is small a, as we have seen here. Now, first we will check what is the size of A. For size of A, you have 3 and 6. 3 represents the number of rows and 6 represents the number of columns. Now, for size A, 1, it only gives you the number of rows A has. Similarly, A, 2 will give you the number of columns A has. Now, I want to see what is A3, 2 in the third row, the second corner. So, I just again this is capital A. Now, capital A 3, 2. This is the third row and the second column. This value is 8. So here you can say A3, 2 is 8. Similarly, for B, B3. Now, if only one of the index is given, note that array is always two indexes. One for the row and the other for the column. But if only one index is given, it will calculate from top to bottom and then go from column to column. It will start with 1, 1. Now B2 is B2, 1. Then B3 is B3, 1. B4 is B4, 1. B5 is B5, 1. B6 is B6, 1. B7 is B1, 2. I change it to 7. So the value is 3. Here you can see the value is 3. Now again, if I want to calculate multiple values, now here you will I just displayed A. So I want all the values in the second column, 3, 4, and 8. So I'll use command A from 1 to 3, from first to the third row, and the second column. Then we get 3, 4, and 8. Now again, if I want to find all the values which are equal to some value that I want, let's say I want to search among this array, what are the indices which have the value. Now let's say I want to figure out among this array B, which indices have the value 4. So I'll use this command find. Find the equal is used 2 times to indicate equality. So I want to find which all values are B equals to 4. So here you can see this 3, 2. B 3, 2 is 4 and B 5, 2 is 4. But the answer will be in single indices. So again, single indices has to be interpreted likewise. So B8 is actually B 2, 2. These 6 values, then 7th value, and then the 8th value. Then this is the 11th value. Understood? So moving on, we can also reshape and rearrange the arrays. But one thing is to note that the new size is always given in rows versus column has to be same. The number of elements has to be same as the original matrices. So now if I have matrix A of size 3, 6, the number of elements are 18. So I have to now maintain the number of elements. So if I reshape, A1 is reshaping A from whatever size it was to 1 to 8, 1 by 18. So one row with 18 columns. So now again you'll see it will go from top to bottom. So 1, 2, 7, then 3, 4, 8, then 5, 6, 10. Here you can see 1, 2, 7, 3, 4, 8, 5, 6, 10. So this is the reshaping that you can use. You can also convert this 2D matrix into a 3D matrix. So for 3D arrays, you will have layers of 2D arrays. So now again I am reshaping from size of A to 2, 3, 3. So there will be 3 layers of size 2 by 3. So 2 rows, 3 columns, and 3 layers. And again following the same order. So I hope you now have understood the basics of arrays and what are the operations we can do in arrays. So in the next video, I'll be explaining how plots work in MATLAB. So stay tuned and I hope you learned something today.